Tech Revision with Mrs. Swanee Pooh. Hi everyone, in this video I'm going to cover some of the new methods of manufacturing that are mentioned in the specification, the ones that you might need to have an awareness of. The ones that you need to know about are, we've got electro-hydraulic forming. I just want to say really quickly, none of these are too complicated apart from this one. This one's a really odd one. Physical vapor deposition is a really odd one. The rest of them are relatively simple to understand. But we've got electrohydraulic forming, direct metal laser sintering, which is basically 3D like metal print, 3D metal printing, fiber injection molding, which is super simple. Don't even worry about that one. This odd physical vapor deposition one, and laser welding, which is as simple as it sounds as well. So what I'm going to do is, for each of the manufacturing techniques, I'm going to show you a YouTube video. It was quite tricky to find really good YouTube videos for all of these, so bear with me if some of them go a little bit off topic, but hopefully they show you the process in enough detail. So the first one I'm going to show you is called electrohydraulic forming, and the video will hopefully come on now. Okay, so you're back from that video. So electrohydraulic forming is actually a really clever technique. It basically uses almost like a explosion almost to kind of like shock waves within a metal part to create the actual shape. So rather than you know, pressing it into shape outside of the product, basically what you do is submerge the part in a liquid, and then an electric arc is discharged inside the part. So imagine if this part was just like a tube or something to begin with, and this one actually has a mold around the outside, which is where you want the part to be shaped into. So imagine we've got this metal tube, and then suddenly we get an electric arc and it goes boom inside, and all the pressure from that shock wave actually forces the forces the metal tube to take on the shape of the mold. So it's quite a clever way of creating quite strange shapes, quite often used on car parts like exhausts and things like that. But it's quite a unique and interesting way of creating shapes, and you can see we've got unrestrained, where there is no mold around the outside of the part, and it just literally takes on the shape of what, you know, it just that where the reaction is kind of concentrated, it kind of bulges out. And then you've got this restrained expansion, where you have actually got a shape that you want the part to go into. So when there is this kind of shock wave inside, the metal just flips out, pushes out, and takes on the shape of the mold on the outside. So electrohydraulic forming is basically in a liquid, and the use of electricity to create kind of like a mini explosion inside a tube or a metal part to get it to go into the shape that you want it to go into. Hope that makes sense. On to the next one. The next one, I'm going to show you a video now.
Direct metal laser sintering also known as DMLS, is an additive manufacturing technology that creates metal parts directly from 3D CAD data without the need for tooling. DMLS utilizes a variety of metal and alloy materials, such as stainless steel, cobalt chrome, and Inconel, to create strong, durable parts and prototypes. DMLS is an excellent choice for functional metal prototypes, high-temperature applications, and end-use parts. The DMLS process begins in the same fashion as other layer additive manufacturing technologies. A program takes 3D CAD data and mathematically slices it into 2D cross-sections. Each of these sections will act as a blueprint, telling the DMLS machine exactly where to sinter the metal material. The data is then transferred to the DMLS equipment. A recoater assembly pushes powdered metal material from the powder supply to create a uniform layer over the base plate. A laser then draws a 2D cross-section on the surface of the build material, heating and fusing the material. Once a single layer is complete, the base plate is lowered just enough to make room for the next layer. More material is raised from the cartridge and recoated evenly upon the previously sintered layer. The DMLS machine continues to sinter layer upon layer, building from the bottom up. As the part is built, support structures are added to give supplemental strength to fine features and overhanging surfaces. The completed part is then removed from the base plate and treated with an age-hardening heat process to further harden the part. Any support structures are also removed at this time. With numerous surface treatment and hand polishing options available through service providers, DMLS parts can be used in highly cosmetic applications. Typical uses for DMLS include tools and manufacturing aids, small integrated structures, dental components, surgical implants, and aerospace parts.
Right, now hopefully you are back from that video, and it's a relatively simple idea. It works differently to something called FDM, which is fused deposition modeling, which is how our 3D printers at school work. So basically, fused deposition modeling just means that each of the layers are melted together, they fuse, and they are deposited onto a bed. Now this is slightly different. So for example, I don't know if this animation is actually working on the screen for you, but you have some metal powder. So for example, it could be titanium. And what happens is a layer of powder is pushed on top of the bed, and a laser melts each of the individual layers, and it just continues to build and build and build and build. So there are some massive advantages to this. Before they use this process to create really complex metal parts like this, they would have had to machine them from a solid block. So it could have been something like a cube of titanium. And the massive advantage is of this, there's a lot less waste, because it only melts the individual little bits that you need. The rest of this powder around the outside can be used again, so nothing is wasted. Only the part then kind of like emerges from the metal powder, and you can see where the laser has fused the individual parts together. So it's much less waste, it's quite a bit quicker. You can also make very complex and very strong parts, and these are used in things like the aerospace and all sorts of different applications now, but that's kind of where it's starting to be used a lot more. So that is basically 3D metal printing, works with a laser, and sintering just kind of means melting together. And yeah, some big advantages because it's less waste, a lot quicker, and you can make some really complex and unique parts, but they are very, very strong. Right, the next one is super, super simple. It's basically injection molding, but rather than it just being plastic granules, they actually put chopped up carbon fiber or some kind of fiber like reinforcement within the polymer granules making a part that is a lot tougher and has, that's terrible, that does say tougher, and it has enhanced properties. Okay, so I'm going to show you a short video now. And now hopefully you are back, and it makes a little bit more sense that it's just basically this exactly the same as injection molding, apart from you have a composite type of fiber that goes in with the plastic granules that is injected, and therefore your part is going to be a mixture of polymer but also bits of carbon fiber that are going to make it a lot stronger, so enhanced strength. That could be compressive, or it could be tensile, but it would just give enhanced properties. Okay, hope that one makes sense. So this is the slightly strange one that I was talking about, which is kind of, I feel, relatively similar to something like electroplating. I'm not saying the chemistry is similar, but it has kind of got links to it in terms of the atoms from a source material here are actually being vaporized, and they are being transferred over onto another piece of material. So basically what this process does is it creates a thin pure metal or alloy coating on the surface of a material. It's usually for metals. Okay, so the source material, say it's something like titanium, or it could be platinum, or it could be any kind of metal. An electron gun is fired at that metal, which vaporizes the atoms. They travel over to the, you know, could be a steel, could be whatever, and they form a coating over the top of that material. So it gives a really high quality coating, but it is completely adhered, so stuck to the surface. So it's not going to be scratched off, it's not going to be dented. It gives a very high quality coating over the top of that metal. So I'm going to show you a quick video now which hopefully gives a bit more of an idea, but this is a finishing process similar to like electroplating or anodizing. So I'll show you the video now. And you're back, and you might still be a bit confused by this. It's such a funny finishing technique. Hopefully it's not one that comes up, but it's one that you do need to just have an awareness of. Physical vapor deposition. Okay, this is the last manufacturing technique that you need to know about. It's called laser welding. Remember to always spell laser with an S, because laser actually is an acronym. So it stands for light amplification of the stimulated emission, bit of a mouthful, emission of radiation. Radiation. Okay, so that's why it's important that the S, so don't ever spell it with a Z like some people do. But laser welding is a really simple process to understand. I'm going to show you a quick video now. Hopefully you're now back and you understand that it just uses a laser, like the similar kind of laser that we might use in our laser cutters that we have. So it could be a CO2 laser, it could be a different type of laser, and it can be used to join together metals or actually thermoplastics to form a weld, so to join them together. And now, because it's such a concentrated heat source, in thin materials, it can be very, very high speed. So in contrast to something like MIG welding or TIG welding or oxyacetylene welding, laser welding actually produces a much smaller area that the heat is kind of acting on. So there is less deformation or deforming, less deforming of the part. It can be a lot quicker, and it's a lot more accurate than using some of these techniques. Okay, so it's a lot quicker, and it can also produce really narrow, deep welds on kind of thicker materials. So laser welding, much more accurate. It can be automated as well, so it can be done by a worker, but also it can be a fully automated system which can bring obviously a lot of benefits, including making it quicker, making it more accurate, removing human error. So there we go, laser welding, that is the final manufacturing technique that you might need to know about. I hope that was useful. See you on the next video.